This is a simple series circuit with RS being the line resistance and RL is the load resistance. VS is a supply voltage which can be DC or RMS for both. It will be valid, and RS and RL we are just considering resistive circuit here. So we need to find for what value of RL, for what value of line resistance the maximum power will be transferred to the load resistance. So we need to find that value. So let's say what is the current here, because maximum power is I square, power basically is I square RL, power to the load, and I is Vs over R L plus Rs. So that's the current here, sorry, it's squared here, so like that. Yeah, so that's current, and square is the power, but square into RL, so that's I. So if we do the, becomes RL square plus 2 RL RS plus RS square times RL. Now if I divide both numerator and denominator by RL, it becomes RL plus 2 RS plus RS square RL, like that. Now what we need to find is what is the maximum power. So for power to be maximum, for this term to be maximum, since Vs we are considering for a fixed voltage, fixed supply voltage, this is constant, so the whole term will be maximum when the denominator is minimum. So we need to find what is the minimum value there. So we can do, what we can do here is, here we need to differentiate this one D. So in terms of load resistance we need to find the line resistance, so we will just differentiate this part, RL plus 2RS plus RS square over RL, and when we differentiate, and we will equate this to 0 to find the minimum value. So when we differentiate this one, the first one becomes 1, the second one, this goes away, it's 0, and the third part is RS square, and this is in the denominator, so this one is actually becoming negative sign because the power is a -1, RL to the power -1, and when differentiated it becomes negative here, and RL square. So we will equate it to 0 to find the minimum value, or find the value actually. So RL square RS square is equal to 1, or RL RS is equal to plus minus 1, say. So that means the line resistance will be equal to plus minus RL. So basically we are just taking the positive value, since we are considering the only resistive circuit, so it's just R, the positive value. So we can see that maximum power is transferred to the load when the line resistance is equal to the load resistance. So line resistance, and so what happens in that case is half of the power is actually dropped in the line and half is delivered to the load, because both are same resistance. And this one means the efficiency is just 50%, because half is dropped in the line anyway. But this one is not a feasible situation for power system, because huge amount of power will be dropped in the line, which we don't want. But for communication circuit this is fine, because we are dealing with small power and we want the maximum amount of power to be delivered to the load, even if half of it is lost in the line. Since we are dealing with small power anyway, it doesn't matter. So the maximum power transfer is the criteria that line resistance is equal to load resistance is important when we deal with small power in communication circuit. But for power system, power transmission, we want the line drop to be as small as possible. So we want the line resistance to be as high as possible, so that the drop there is, because the current will be less than, and the drop will be, yeah. So anyway, I just wanted to derive this formula here.